Thank you so much. So, getting your customized openSUSE kernel on OBS. I'm Shung-Hsi, and I work for SUSE. I'm based in Taidong, Taiwan, which is quite a beautiful place. Come visit and come find me. So I work as a kernel engineer that mostly works on BPF part, BPF subsystem in the SUSE Linux and the openSUSE Linux. So if you're interested in BPF, also come and talk to me. I'll be interested. But for now, the main topic is kernel and OBS today. So I'll start with some backgrounds and then move on to the problems that you'll be facing if you want to customize the kernel and the rationale that why would you want to use OBS for this. And also move on to how exactly you can customize the kernel on OBS in a way that works well. And there's actually several ways that you can do that. And because there's several ways to do the customization, I'll also make a comparison between the method. And finally, ends with a takeaway. So, background. The Linux kernel probably doesn't need much introduction. It's the core of the system. But the important part in this talk is that it talks to the hardware. Without a driver for the Linux kernel for that hardware, the Linux kernel cannot use it. So you need to have a driver if you want to use it for a specific hardware. And it also provides some abstraction and some feature. Sometimes the new feature are really nice that you want to use. It will make your life easier. And OBS. OBS is the open build surface. If you are at the last talk, there's a good introduction to OBS in the previous talk in this room. For our purpose, you can just see it as a build surface. So simply put, it's a surface that can produce RPM packages for you in our use case. And more than that, it can compile your source code into binaries. So you don't have to compile it yourself on your laptop or on your machine. And more than that, besides compiling and producing the RPM packages, it also hosts them. So you don't have to host them yourself. And the open build surface provides two interfaces. One is the API interface. Usually you interact those with the OSC command line tool. But it also have a web UI, which is really nice. I find it very intuitive. And it can get about almost all the work done just by using the web interface. So problems. What kind of problem would you be facing? Would you think about customizing the Linux kernel? So here's an example. For example, maybe your company or maybe your customer require you have some security hardening on the Linux kernel. But because of some reason, the openSUSE does not enable that feature, and you want that enabled. Well, now you need to customize the kernel. Or maybe it's not security related, but maybe you have some hardware, you have some device that you want to use. And turns out the openSUSE kernel also disable it. Maybe we think that there isn't enough user to justify it, but for some reason we disable it. In that case, you want it enabled. That also requires customization. Or maybe it's slightly worse case, you have a hardware, turns out there's no source code in the Linux kernel tree, but you have to get that source code somewhere and use it. Well, in this case, it also requires some customization. And suppose you solve that problem, so all the problem of supporting a new feature, and you have now built a kernel that has been customized on your laptop. Well, now you have a new problem. So it's only in your laptop. How do you ship the customized kernel to all the devices that you're using? Like, if it's only one device, using USB to transport it may be fine. But if you have like 10 or 1,000 machines, that's not feasible. And more importantly, you want to transport it in a secure way. You don't want it to be changed and modified and install malware on those. And suppose you successfully shipped all those kernel into the machines. Now you have another problem, like if you have a security fix that have to be applied, how do you do that? Like, do you have to go through all the process, building the kernel, customization? and then moving all the kernel image to your machine that goes through all that again, which can be quite cumbersome. So that is also a problem. So a short recap, why do you want to customize kernel? Well, the reason that you want to customize kernel usually is because there's some missing feature. Like you want it to support some hardware, or there's some cool feature that you want to use that would make your life easier. But on the flip side, instead of missing feature, it could be that there's too many features in the kernel image. And that could be a bad thing because more features means more attack surface. And one way to reduce the attack surface is essentially ship less stuff, ship less feature, and you will be less affected. And another pretty good reason is that maybe the too much feature causes the kernel image to be very bloated, to be very large in size. If you ship less, then there's smaller size, and it saves the storage space and saves the network cost. And there's also some reason not to customize. So if you customize the kernel, you have to support the new customization. And I think more importantly, one of the downside of customization is that that kernel will not be tested by the OpenQA, which will catch a lot of bugs for you. So that's something to think about. And OBS. So we'll be using OBS because, exactly as said, it builds the RPM package for you. And so you don't need to use your personal laptop to do that. It has some resources, some worker that openSUSE provides that will build the kernel image. And besides that, after it builds the kernel image, it hosts the kernel RPM packages for you. And it distributes it in a very secure way, so it will have some signature that the client machine can check and validate to make sure it's not tampered. And besides that, it also supports many architecture. For example, if you are using ARM, then you might not have ARM, excuse me, ARM on your laptop, so you need to find some machine with ARM to build it faster. Well, if you use OBS, that's not something you have to worry because if I recall correctly, there's, I think, ARM worker that help building. All right, so far so good. So before I head to the customization part, anyone have problems? Or questions? All right, so customization. So there's actually 3 ways that you could do customization and have it work on OBS. So the first method is the add-on method. And this is called the default method to do the customization. If you read the kernel documentation on the openSUSE kernel documentation on this, this would be the recommended way. And to use this, you have the patches that you want to apply for customization and the kernel config both managed in the OBS in an OBS repository. And the good thing about this method is that you could use something called OBS link. And what you do is link your OBS repository to the one provided by openSUSE. And the advantage of that is that every time the openSUSE main kernel is updated, your customized kernel actually also get updated as well. So you don't have to update it yourself to fix all the security issues, which is like super, super nice. And that is a feature provided by OBS. Now, the next method is a more lightweight method. So what you do is instead of having all the patches and config, you just have a single RPM specification file, just one file. And what that file does is just repackage the existing RPM. So what it does is that it takes the kernel RPM package provided by openSUSE, and it goes into that and just grabs the file, grabs the kernel module and some other necessary file that you want, and repackage it into a new RPM package. That way you can get rid of the models that you don't want to use, and the file will be smaller. So the third method is a git-based method. It's actually the method that was used by the SUSE kernel team. So instead of using OBS repository to manage the patch and config, we use Git. And the good thing about this is that since it's in Git, it can be it can be served on different servers. For example, it can be hosted on GitHub or such. And also, there's some because it's Git, collaborating on it is very easy. So let's move on to the more detailed part of the customization. So first, the default add-on method. So the requirement for this is there's a bit requirement, but not that much. So you need OSC, the command line tool, or you could use a web browser actually. You need tar and Archiver. And if you're working with the patches, you'll need a tool called diff to generate the patch. And the workflow for this, if you're just trying to change the kernel configuration, it's quite simple. The first step you have to do is to branch the kernel package on OBS. And depending on what version of the distro you're using, if you're using Leap 15.6, you choose the kernel default package for Leap 15.6. And with OBS, when you branch a package, when you branch an OBS package, it creates that OBS link for you. So whatever package you branch, when it's updated, your branch of that package will be updated as well. So be sure to use branch. And the next step is to create something called config.addon.tar.bz2. And I'll talk more about this later. But you create that, and it should contain the configuration that you want to change. And after you have that, you just upload it to your OBS package that you have branched, and it should build the kernel with such customization for you. So let's look a bit more on the config.addon.tar.bz2. Inside, it's actually a directory structure. And in the directory structure, it will have the first level of directory is actually the architecture. So for example, if you want to customize only on the usual x86-64, you also do that. Now, under the directory is the actual file of the configuration that you want to apply. So it will look something like this. So the kernel config usually take this format, like config something something and equals y. That means that configuration is enabled. Now, the default here is a flavor of the kernel. So what happened is that while we provide the kernel, there's some specific tweak that we do, and different tweak we have is a different kernel flavor. But as far as we're concerned in this talk, the flavor is always called default. Default is the kernel that most people will be using. So what you do is have this config.addon directory and have it structured like this. And after you have put the configuration you want into individual default files, you archive it with tar and bz2, and then put it in the OBS project that you have branched. And that is actually all you need to do for a configuration change. So if you want to do more than configuration change, for example, there's some code in the Linux kernel that you want to change, it's a bit more work, but I think still doable. For this, you need to grab the source code of the openSUSE kernel. And this is hosted on GitHub under openSUSE kernel. So you can just grab an archive of it, download it, extract it. And for this to work, I think you need 2 copies. So the reason that you need 2 copies, you need to use diff to generate the patches. And for that, you have to have the original copy and the modified copy. So one thing you can do is extract it 2 times and go to the first extracted copy, do some modification there. And after you're done and make sure stuff work, you use diff and give it the directory of the original files and also the directory of modified file. This should produce a patch file for you. And with that patch file at hand, you generate a patches.addon.tar.bz2. And you still, if you're starting from new, you still should branch the OBS package. And you place this patches.addon.tar.bz2 into your OBS package, and OBS builds a kernel with the changes for you. And so a bit more into the what does patches addon.tar.bz2 looks like. It's actually mostly just files. It'll have a series file which contains the name of the patches and also the patches itself. So the patch will look something like this. The first upper part is the example of patch. This is the diff format we use for patches. And the second is a series file that just contains the name of the patch. And the reason that we have a series file when we already have the patch itself is that you might want to apply the patch in some specific sequence. So with the series file, it allows to specify which comes first, which comes later. Because sometimes if you switch the sequence, there could be some conflict and the patch will fail to apply. So with that, that covers the essential first kind of method, the add-on method for applying kernel config change and the patch change. Now we move on to the simpler RPM spec that does the repackaging. So for that, the only tool you need is probably a web browser if you don't want to use command line. Web browser can does the branching and also it allows you to edit a specification file just through the web UI. And for that, so again, we still use branch, although I don't think it's really necessary, but branching should still be good. And after you branch a project, you go into your own branch OBS package and modify the specification file. I'll talk more about it later. And one thing you would probably like to do is to rename the spec file and the project to something else. Because the kernel default base is actually something that you'll see on the VMs. So you might want to change your kernel package name to something different so it's easier to differentiate and also so it will not conflict with the original. So for the modification, it's actually quite easy. What you need to do is to basically, you can choose what kind of models, kernel models you want to be packaged. And it's all listed in that specification file. So if you want to remove something, you just remove the kernel model name from there. And if you want to add something, you also find some place to add. The most important part, I would say, is just to make sure that the models RPM macro has the kernel model that you want to use. Other than that, other this are more just helpers. So the modules one is the one to look out for. And that's all actually for that method. It's quite easy. The third method is the one I said is the method that used by SUSE kernel team. And this is actually quite complicated, so I'll just go over it briefly. But first of all, there's a lot of tool you need. You need this Git, and you need something called Quilt. Quilt is a tool that helps you manage patch. It applies and unapplies patch and makes patch-based development easy. Like if you started working on the tech after Git is used, you probably never heard of Quilt. I never heard of Quilt before I joined SUSE. But that is kind of I think one of the de facto tool to manage changes in the same way before Git comes in. And there is actually quite a lot of steps if you want to work on this way. And if you're using the kernel source, it's git-based method, you probably are not looking at changes the kernel config, because if you only want to change the kernel config, you would likely have a better time using the first add-on method. So I'm going to talk about patches here. So the way you do it is you first clone the kernel source.git on the openSUSE GitHub repo. And notice before it's kernel.git. So the kernel.git has the directory structure just like the Linux kernel source tree. But the kernel source git is something different. Inside, it doesn't look like the Linux kernel source code at all. There's just a lot of files that are .patch. So after you clone it, you need to use a tool that's inside it called sequence patch and apply the patches. You can apply to certain point in the patch, and when you have arrived at the location you want to start modification, you change into the directory called temp current. And inside there, you'll find the same structure as the Linux kernel source tree. There you can do your modification. And the modification should be done with quilt. And after the modification is done, you have to do something more, like refresh patch. So that way the patch is, I guess, effective. It's a lot of things to do. So after there's a patch, you can go back to the directory and use a log command to commit the patch. And after you've done all the work, you probably want to push that Git repository somewhere to be shared and to be continuously worked on. So then after all those steps, you can finally push your work to OBS. And I won't go into details. This is also some helpers provided by the kernel source Git. So as you can see, this is actually quite a complicated setup. And there's a reason for that, and I'll go into that later. And that, I think that makes a good time for the comparison. Like, why does that method have to be so complicated? So the first method, the add-on method. So I think the add-on method is usually the right place to start. It has a very good balance between the easiness of doing changes and customization, and it is also not too hard. It is quite easy to maintain because OBS will update the changes for you. But there is some chance that your patch might fail to apply and you have to fix it manually, but I think it's a very good method. So the second method is the RPM spec method. So this is very, very easy. You can do all the changes in just your web browser. And one thing that is nice is that it has identical binaries with the openSUSE upstream kernel packages. So if you have some maybe security scanner or something that requires the binary to be the same, maybe this situation will be easier for you. And it is also very low maintenance. It can hardly go wrong. It's just repackaging. So it should be very easy most of the time. The only downside with this easy method is that you cannot do that much customization. For example, if there's some kernel config that you want to change, sorry, like this cannot work for you. It can only remove and add kernel package supplied by the openSUSE kernel. And right now, the third method. So again, this is the method that was used by the SUSE and openSUSE kernel team. And the reason we use that is that it's very flexible. You can do almost any changes anywhere, and in a way that usually does not conflict with previous changes. It's a bit much to go through, but it's a very, very flexible method. And besides being flexible, it also scales very well. We have a lot of developers working on this at the same time. And because we use Git, we can use like a pull request, merge request workflow, and that avoid many of the conflict that you'll be facing if you only use OBS package to collaborate. So the bad part is that if you use this method, you need to push the changes to OBS every time. So OBS cannot automatically update the kernel image source code to the latest version for you. You have to do this yourself. And the workflow is quite complex. It takes more resources and tooling you have to learn. And it's mostly command line only, so it's not very friendly for beginners. And that covers all the methods to customize the kernel. And now I'll go into the takeaways. So, long story short, sometimes there's some requirements that you have, and it can only be done when you customize the kernel. So when you do that, it's a pretty good idea to use OBS to help you with that. And when you do, one of the best methods, I think, is to go with the add-on method. And if you find that to be too restrictive, usually not, or maybe it's too much, you try to move to the other two methods and see if that works for you. And here's some example. There's 3 examples for the 3 different methods. So if you're interested, you can definitely look at those. I'll post the slide sometime later. And here's are some references that are used to make this presentation. And this entire presentation is actually made of a single email thread, the first one. There's some very knowledgeable people commenting on that thread. So if you're interested, also you can look at that. And all right, that's the end of my talk.